This resource looks at contextualizing literacy and numeracy activities. This module will enhance your ability to contextualize the activities in the learning progression resources and provide examples of authentic contextualized numeracy activities. We're going to review the activities sequenced in this learning plan, which was designed to address the skills of employees who are required to count stock on pallets on a daily basis within a busy warehouse. Keep in mind that the majority of learners had been assessed at step 3 and we'd mapped the task at step 5. We're going to review how these activities were contextualized within a classroom context. Now, we had mapped the task at step 5 and we had assessed learners and found the majority were at step 3, some at step 4. Now keep in mind that the learning progression suggests that a learner at step 3 is able to multiply two single-digit numbers, and they can do this using known multiplication facts or repeated addition. So that means they could work out 6 times 5, 6 fives, perhaps by counting up 5, 10, 15, 20, 25, 30, or perhaps as a known fact, 6 fives are 30. However, let's take a quick moment to have a look at step 5 skills. Now, in contrast, step 5 on the multiplicative progression is to be able to multiply two multi-digit numbers mentally using partitioning strategies. Pause the clip and attempt to solve this problem without writing anything down. Now, solving this task mentally requires step 5 multiplicative skills. And most likely, if you are able to do this, you use partitioning strategies, which means you're able to break various numbers into component parts. For example, you might have broken the 32 into 30 and 2, or you might have broken the 12 into 10 and 2. Being able to do this provides you with multiple strategies with which to solve the problem. 32 times 10 is reasonably easy to calculate. The remainder, 32 times 2, is also reasonably easy to calculate. 320 plus 64 then has to be worked out in the working memory, and this equals 384. And thus we've solved 32 times 12 mentally using partitioning strategies. And again, this represents step 5 on the learning progressions, and this is the target step for employees attempting to count the boxes on the pallets. Okay, so let's look at activity number 1 on our learning plan. Discuss and apply a range of strategies to solve a multiplication problem. And this is taken from the activity found on page 35, Understanding Multiplication. And the resources are examples of boxes with various quantities and learner examples. This activity, Understanding Multiplication, looks at moving learners or transitioning learners from repeated addition to a model of multiplication where they use multiplication facts. And if you look at the teaching points there, you can see that we want them to learn that there are alternate ways of deriving the answers to these problems that doesn't involve repetitive counting. Now, remembering that the learners at this point are multiplying two single-digit numbers, the way we did it was to show them a group of boxes, a single digit, so in this case 5 boxes, each with a quantity of 6 within it. And all we want the learners to do is to discuss and come up with multiple ways to calculate how many overalls, which was the product, are in these boxes. And we just write them on the whiteboard, or we just get them to generate it and discuss them. And we might get 3 or 4 or 5 different ones. For example, one of the more complex ones would be we know that 2 6s are 12, so we might just go 12 and 12 is 24, and then one more, and so on. And so what we're trying to do is we're trying to clump those numbers together, but really show that there's multiple ways of doing it, and to discuss these and to write them on the board. Now, what we'll do is we'll continue this activity and continue to explore various strategies that learners have, and we'll begin to increase the number of boxes or change the number of boxes, still remaining with single digit by single digit until we've got this activity done. Now, rather than just have this in a long session, What we did is we did 10 minutes of this in the morning and 10 minutes directly after lunch. And again, we showed pictures, or in some cases we had real boxes on pallets in the classroom. And we asked the learners to come up with a whole lot of strategies for solving what it is. We write these, we show them, and we show that they're all good methods of getting to the final product. In doing this, we're also beginning to ask them to evaluate which strategies are the easiest, which make sense, and which are the most efficient. This lasted for a little over a week, which is in total probably about 5 to 6 sessions. Now, once the learners were comfortable with single-digit multiplication and discussions, we moved on to activity number 2. Partition and recombine numbers to multiply multi-digit numbers with single digits. For example, 5 times 15, 5 times 12. And this activity is taken straight from multiplicative strategies found on page 39. This activity is very simple and it's designed for learners who are at step 4 of the learning progressions. We give them an equation, 31 times 5, break them into groups and ask them to come up with at least 3 strategies for solving this problem, and then we'll ask them to demonstrate these strategies to the class. Now, in the Learning Progression Resource Book, it suggests that you use sticky notes with the learners, which you can do. Personally, I've found it just as easy to ask learners to come up to the front of the class and demonstrate their strategy to the class using the whiteboard. This activity is short, it should take no longer than 5 to 10 minutes at a time. So we'll give the learners a problem, 31 times 5, and ask them to provide strategies. For example, 31 times 5 might be broken into 30 times 5, which they will demonstrate how they work that out. 30 times 5, 150, plus 1 times 5 equals 5, in total 155. A second strategy that some learners come up with and that others haven't seen is to double the 5 to 10, 31 times 10. Usually this is derived as a known fact, 310, and the learners then halve 310, 155. Some learners will recommend doing an additive algorithm where we add 31 5 times. The main point is that learners are exposed to a wide range of strategies with which they're able to see that some are more efficient than others. And as we give them different numbers to work through, they begin to understand that there are different strategies which are more or less appropriate to different numbers. For example, 49 times 5. Some learners round this to 50 times 5, and they represent it as such. 50 times 5, 250, but they know that they've added one lot of 5 too many, so they subtract the 5 to get 245. Now, a second strategy again they might come up with is to double the 5. 49 times 10 is 490, and then halve that, 245. Or a third strategy might be to partition the 49 into 40 and 9. 40 times 5, many learners will know 4 times 5 is 20, so 40 times 5 is 200, plus 9 times 5 is 45, put them together, 245. And we'll continue to give them multiplication sums to work on as time goes on. Now, in my personal experience, 5 minutes in the morning, 5 minutes after lunch, for a period of up to 2 weeks, is entirely appropriate to give learners a good understanding of how this works and to allow them to experiment using new strategies. The idea behind this activity is that when learners see and understand a strategy that works well for the sum and that makes it easier, they will adopt that strategy for themselves, particularly if they're given opportunities to practice it. Now, once we're sure that the learners have grasped and understood the learning points from activity 2, we move on to activity 3, where we want the learners to mentally partition and recombine double-digit multiplication sums. So this is a double digit times a double digit. And as you can see in the resources, we've got sticky notes, palettes with boxes, and learner examples. Now, the way we contextualize this activity is to put it into the context of the task, which is counting boxes on pallets. And as you can see, we'd use paper-based models, but we also used real models. So we got an actual pallet with boxes, and we put stickers on the boxes that we could write the quantities on with a whiteboard marker and simply erase and start again. However, a couple of key points. Through our mapping process, we'd realized that most deliveries of boxes are in multiples of 6. This meant we could also teach some known facts around multiples of 6 and multiples of 12. For example, if the bottom layer of the pallet was full, this meant there were 12 boxes. 12 times 12 is 144. We could teach this as a known fact, but would also use these examples in the class as we did with the other activity, 10 minutes in the morning and 10 minutes after lunch. And this activity would allow learners to come up with multiple activities for determining the amount of stock on the pallet. They would do this in groups, and then they would describe their solution. Through this process, learners were able to continue to see other learners' strategies and to adopt and practice them themselves. In summary, we were able to use the learning progression framework to transition the learners from step 3, single-digit multiplication, to step 5, double-digit with double-digit, by developing partitioning skills and giving learners exposure to lots of different strategies and slowly transitioning them through those stages. The activities in the learning progressions were contextualized to the real-life task, which was pallets on boxes, and this included paper-based models of that, as you've seen in the pictures, but also real models of this in the classroom with the boxes. And this is how we contextualize the activities within the learning progression resources.